My name is Professor Tim Jackson. My research has always been in the area of bioinorganic chemistry. When I was a graduate student, I looked at metal-dependent enzymes, in particular enzymes that use the metals iron and manganese. And the lab that I was in used spectroscopic and computational methods to link the electronic properties of those metals with the chemical reactivity of those enzymes. After my graduate work, I did a postdoctoral research stint where I learned how to make synthetic model complexes of metalloenzymes. And my lab now uses that approach in its research. My research program is fundamentally interested in how nature controls the reactivity of metal centers for electron transfer reactions or electron-proton transfer reactions. And we understand those reactions by making model systems that mimic intermediates that have been proposed for the enzymes. And we use kinetic methods and spectroscopic methods and computational methods to understand the reactivity of those models. We're essentially interested in learning how the environment of a metal center dictates the chemical reactivity. And ideally, we could use that knowledge then to make new tailored molecules for particular reactions. So the graduate students in my lab learn a lot of different techniques. They make molecules in the lab. They characterize those molecules using a wide range of techniques. We use some experimental methods in-house, like nuclear magnetic resonance, NMR spectroscopy, electron paramagnetic resonance. Students in my lab also travel to national labs to do X-ray experiments that you can only do at specialized facilities. And so the students are in lab, making the molecules, collecting the data, and then analyzing the data. Students in my group will also use computational methods to augment a lot of the spectroscopic data that we collect. So it's really a collaboration between me and the students where they make exciting discoveries in the lab, and then we talk about what these discoveries mean and write papers and share that information with others. Some students from my lab have ended up at other universities and colleges, either as tenure track faculty or teaching professors. I have students who are at national labs doing research in nuclear chemistry, and other students who have positions in the pharmaceutical or biotech industries. My lab collaborates with some groups on campus. We have had a long-standing collaboration with Bala Subramaniam's lab. He's in the Department of Chemical Engineering. We have also collaborated with groups in other countries, so with groups in France, labs that are experts at electrochemistry. We also have collaborations with groups in India and are pursuing a new collaboration with a lab in Israel, where they've made some interesting new molecules that they would like us to characterize. So we use a lot of the core lab facilities, X-ray crystallography, the nuclear magnetic resonance labs. We also use the high-performance computing cluster for our computational chemistry research.